Okay, so we have this one where they're asking us to determine the amount of interest. So before we can figure out the interest, we have to figure out what the future value is. So we've got 9 years and it compounds semi-annually. So 18 is going to be our N. We have a 10% interest rate, and that is also compounded semi-annually because these are always going to match. They'll always be the same. So 10 divided by 2 gives us a 5 as the IY. The balance, the 2,657, hit the plus or minus button. See, my finger isn't the greatest. Okay, so hit the plus or minus button to make it negative. That's our present value. We've got no payment. And then we're going to compute the future value. So if we put those into our calculators, I get 6,394.39. And then from that, I'm going to subtract the $2,657. And then the difference is going to be the interest. Whoops, I got to put that in my calculator, right? And that gives us $3,737.39. So then that is our answer there. Okay, then the next one says, okay, they've got $3,300 in their savings account on May 1st. Then she deposits $500 on May 31st, and then $1,000 on June 15th. Find the balance. So if I come over here, clear my canvas. Okay. So then this one's a trickier one. So you have to figure out your days. So you're going to use your second menu and your number 1 to take you into that date function. So if I go into there, my first date is going to be 5/1. And then I'm going to push enter. And then I'm going to arrow down. And then my date 2 is going to be 5/31. And you always want to enter it with the month, the decimal, and then the day. So that's 30 days. Okay, then my next date is going to be May 31st. Oops. So if I arrow back to the top, put in 5.3120 as my first date, arrow down. Then my next date is going to be June 15th. So I'll type that in and push enter. And then that is 15 days. So some of these, I mean, both of those seem kind of obvious, but yet you could just be a day off and then you'll get the wrong answer. Okay, then if I come back over here, we've got June 15th to August 15th. So again, I'm going to start with June 15th. And then I'm going to go to August 15th. So again, go into my calculator, hit my second menu button, my date function. All right, so my date 1 is 6.1520. Push enter. Arrow down, 8.1520 is my second date, arrow down and compute. And that one is 61 days. So that, again, could have been one that's a little bit trickier. So if we jot those down to the side, so my first transaction is 30 days, my second one is 15, and my third is 61. Okay, then I'm going to clear my canvas again. Hello, clear it. There we go. Okay, then we'll come back and we'll start our computation. So for the first one, again, we're going to say we've got 30 days. So that's our N. Our IY is going to be 3.5 divided by 365, because that also needs to be a daily rate. So 3.5 divided by 365 gives us 0.0009589.041. And then while I have that in my calculator, I'm going to just push the IY button because again, it's a long number. You don't want to miss anything when you type it in. Okay, then the present value is what she starts with, 3,300. No payment. And then we're going to compute the future value. So again, 30 is our N. The 0.009589041 is the IY. The 3,300, hit the plus or minus button to make it negative, is our present value. Zero out the payment, and then compute the future value. So that is $3,309.51. Then on that day, though, she adds $500 to it. So if I add $500 to that, my new present value is going to be $3,809.51. So then now if I come back up, let's see if I can erase that. Erase that. If I can. And then we will redo these, okay? Whoops. And my eraser went too large. Okay, so we'll still come down here. We'll be computing the future value. Still have a zero payment. Okay, so then now though my N is going to be 15 days. Oops. There we go. Sorry. Okay, then my present value is $3,809.51. Okay, so then now we put that in. And I'm not going to redo my IY every time because I'm not clear in my tables. So I'll put in 15 as my N, $3,809.51. I will hit the plus or minus button to make it negative. That's my present value. No payment. Compute that future value. So then that gives me $3,814.99. Okay, then on that date though, she deposits another $1,000. So then now I'm up to $4,814.99. And then that I'm saving for 61 days. So again, back to what we had before. So I'm going to go up here, erase these. Okay. And then I'll put in my 61 days, June 15th to August 15th. The $4,814.99 becomes my new present value, and I'm going to compute the future value. So again, make my N 61, type that into the calculator, 4,114.99, hit the plus or minus button, then push the PV button. I'm leaving my IY and my payment because I didn't clear my tables, and those are the same. And then now compute the future value, and I get $4,843.24 if I round it. Okay, so then that is B. But you can see as you look at those, they're all so close. If you were just a day off in any of those computations, that could make the difference, and you'd end up missing that problem. Okay, you don't have one that's that many steps on your test though. A local business then now deposits $350,000 in a 2-year deposit, earning 4% compounded daily. What amount will they have and how much interest will they have earned? Well, here I'll clear the canvas because I'm starting fresh. Okay, so our N is going to be 2 years, times 365. So 730 days is my N. 4% compounded daily. I've got to divide that by 365. And that gives me 0.010958904. And while I have it in the calculator, again, I'm going to push the IY button just because it's so large and it's easy to kind of mess that up. They start with 350,000. We'll make that a plus or minus to make it negative. That's our present value. No payments yet. And we will compute our future value. So 730, push the N button. I already put in that long number as my IY. 350,000, hit the plus or minus button to make it negative, is my present value. Push the PV button, zero out the PMT, and then compute the future value. So I get $379,148.81. Okay, so that's D. And then obviously the interest is going to be the difference. So that's if you take the 379,148 and subtract the 350, that's where this $29,148.81 comes in. But that's really all we need to do because we know that's the right answer. Okay, so then we'll come back over here and we will clear the canvas again. Okay. Find the interest rate paid if the deposit of $29,000 turns into $36,896 in 3.5 years, and it's compounding semi-annually. So our N is going to be the 3.5 compounding semi-annually. So I need to multiply that by 2. So 7 is going to be my N. We are looking for the rate, so we'll skip over that. The 29,000, now this one, it's going to be very important that you hit the plus or minus button. If you do not, you will get an error. That is your present value. Still no payment, so we zero that out. And then our future value is $36,896.10. And then we will compute our IY. So when I put this into my calculator, 7, push my N, 29,000, hit the plus or minus button to make it negative, push the PV button, zero out the payment, 36,896.10 is my future value, and then compute the IY. Now don't stop there though. So you're tempted to because you look and say, hey, look, that's C. It's not because this is still semi-annual. So we need to multiply that by 2, which will give us 7. And that is our annual rate. So that is A. So don't let those confuse you. Always take that next step to turn it back into the annual rate. Okay, we'll come back over here. Clear that canvas. Okay, so then now Barbara knows that she needs to buy a car. It's going to cost her $15,000. Come back over. She's got 8% compounded quarterly, and it asks how much should she invest now. So again, how much should she invest now tells us we're computing for the present value. So we're compounded quarterly. So she's got 4 years times 4 quarters. 16 is the N. 8% a year divided by 4 quarters gives us 2% per compounding period. How much is she investing now? That's our question. So that's what we're computing as our present value. There's no payment. The future value is what she needs. She needs to have $15,000. So then we will compute our present value. So 16, push the N button. 2, push the IY button. 0, the PMT. 15,000 is our future value. And then come back and compute the present value. So that would be 10,926.69. Whoops, did I inadvertently click that D? It's A. Sorry about that. Okay. Okay, then we have Bob deposits $5,000 at the end of each year for 11 years in an account paying 12% annually. Find the amount that he will have on deposit. So this one's easy because it's annually. So then our N is 11. Our IY is 12. The present value is 0 in this one because he's not starting with anything today. He's depositing $5,000 at the end of each year. So this is the, let me bring my cursor up there. That's your keywords, the end of each year. That tells us that's a payment. So then we come back over here, put that in as our payment, and then we'll compute the future value because he's still saving. So 11 is our N, 12 is the IY, 0 out that present value, $5,000 payment. You can make it negative if you want to. It doesn't really matter on this one. And it doesn't matter on all of them, but some of them it will. And then you compute your future value. So that gives you $103,272.92. So that is B. Okay, and then here we have Charles wants to retire in 17 years. At that time, he wants to be able to withdraw $22,000 a year at the end of each year for 17 years. Assume that the money can be deposited 5% annually. What exact amount will he need in 17 years? So anytime we're dealing with the retirement ones, we focus on what he's doing during retirement. So he thinks he's going to live for 17 years after he retires. So that's this part here. What's confusing on this one is they're both 17 years. It'd be nice if they were different. So what we want to focus on though is how much he's withdrawing and for how many years. So that is our N. So 17 is our N. The IY is 5%. We're solving the present value. Anytime they're making withdrawals, so maybe jot that down. If it's a withdrawal, you know you're going to come back and compute the present value. The amount of the withdrawal, the $22,000, that is the payment because it's at the end of each year. So again, those are your keywords there, end of each year, and withdraw tells us it's a present value. And then the future value of retirement is always 0 because the person is dead. They do not need any money when they die. They only need money while they're living. So that hopefully will help you remember too. And then we come back and we compute present value. Okay, so 17 is our N, 5 is the IY, 22,000 is our payment. I typed that in wrong. 22,000 is our payment, 0 out that future value and compute the present value. So they would need to have $248,029.46. Now notice we're a little bit off because they're using the tables and we're using the calculators. I think our answers are a little bit more accurate, but then we're a few cents off in this one, but it is B. So don't let that confuse you with the quizzes. The test, it won't be multiple choice. Okay, so then we come over here. Southwest Dry Cleaners believes that it will need new equipment in 9 years. The equipment will cost $26,000. What lump sum should be invested today at 8% compounded semi-annually to yield $26,000? So our N is going to be our 9 years. Whoops. That's how long they have to save. It's semi-annually. So 18 is our N. They are earning 8%, also semi-annually. So we need to divide that by 2. So our IY is going to be 4. They are asking us what lump sum should be invested today. So that tells us we're computing the present value. So in this one, we have no payment because they just have a future value. They're going to need $26,000 in the future in 9 years, but they want to know how much should they set aside today. So that's our present value. So 18 is our N, 4 is the IY, 0 out our payment. Oops, sorry, I clicked that button again. I don't mean to do that. $26,000 is our future value, and compute the present value. So it's actually C. It is $12,834.33. Okay, then now we want to accumulate $45,000. Interest is 9% compounded monthly. Payments are made at the end of each month for 6 years, or sorry, for 3 years. So if we come over here and clear this out, our N is going to be 3 years. Monthly payments is going to be 36 monthly payments. 9% divided by 12 gives us 0.75 as our IY. We're trying to accumulate 45,000, so we don't have anything to start with today. So we zero out our present value. They want to know what the payments will be, so that's what we're computing if we want to reach the goal of the 45,000. So then we will compute our payment. All right, so come into our calculator, 36 is the N, 0.75 is the IY, zero out the present value, 45,000 is our future value, and then compute the payment. So that is $1,093.49. So then that is B. Okay, then we have now find the least amount that could be deposited today. So that's your keyword. Least amount deposited today is my present value. Your other keyword is that these are withdrawals. So we've got 8% compounded semi-annually to allow $1,875 in withdrawals at the end of each 6 months for 12 years. So if we come over here, 12 times 2, because it's semi-annual, gives us 24 as our N. 8 divided by 2, again because it's semi-annual, gives us 4 as our IY. We're computing the present value, so we'll skip over that. 1,875 is our payment at the end of each semi-annual period. The future value is 0. When we're making withdrawals, we always end up with nothing at the end because we're pulling that money out. So then we are going to compute the present value. So 24 is our N, 4 is the IY, 1,875 is our payment, zero out the future value, and compute the present value. So we get 28,588 and 6 cents if I round it. So, or I guess 5 cents. I don't have to round it, so 5 cents. So D is that answer there. Okay, then now this one, if we come over here, this is using our effective rate on our calculators. So it's the interest conversion. So then if we go into our second menu, and if you look above the number 2, you see this icon V. So that's the function that we're using. So if I go into that, my second menu and my number 2, the first field I come to is this NOM. So NOM stands for the nominal rate. So in this case, it's going to be 6 because it's 6% compounded quarterly. But then when you're inside this field, you have to push enter. So you push in 6 and then push enter. Okay, then you arrow down. And then you're going to, the next field you come to is the EFF field. All right, hold on 1 second. Okay, sorry about that. Okay, so then you arrow down, and the next field that you come to is the EFF, and that's what we're computing. So we're going to go past that and then go down to the last field, which is C/Y, which stands for compounding periods per year. So in this case, it's quarterly, so that's 4. So we'll type in 4 and push enter. Then we're going to arrow back up and then push compute on that EFF field. And that gives us 6.136 or 6.14. So then that is going to be D. And you'll have one of those on your take-home quiz too, and that's the way you got to do it, is using that interest conversion function. So go back to your calculator and use this as your example. Okay, then they have find the amount of each payment into a sinking fund if $12,000 needs to be accumulated quarterly for 3 years. Okay, so our N is going to be 3 years times 4 quarters. So we've got 12 as our N. We've got 6% compounding quarterly. So that's going to give us 1.5, right? And that's our IY. The present value is not, there's nothing, we're not starting with anything today, so we can zero that out. We're computing the payment, so we'll come back to that. The $12,000 is the future value. It's what they need to have for whatever they're saving for. So then we'll say, okay, 12, push your N, 1.5, push the IY, zero out that present value. $12,000 is our future value. Compute the payment. So that's $920.16. So that is A. Okay, then how much should be deposited semi-annually? So this one's basically the same as the one that we just did. So to be honest, I'm gonna skip it. So look back at what I just did on that last one. Okay, then John Thomas bought a new car for $17,136. He paid 10% down and is making monthly payments for 3 years. So find the amount of the monthly payment, and then the interest over the time. Okay, so if we come over here, his N is it's 3 years. So he's got 36 monthly payments. That's our N. He's paying 10% a year. So we'll divide that by 12. And that is 0.833333. The threes just kind of keep going. That's our IY. Now the amount he borrows is what goes into our present value. So he bought the car for $17,136, but he put 10% down, or he's financing 90% if we want to use our complements. So if I multiply that by 0.9 or subtract 10% from it, I get $15,422.40. I'll hit my plus or minus button to make that negative, and that's my present value. We're computing the payment. The future value of a loan is always, always, always 0. So do not ever put the amount that they're financing in as the future value. They're borrowing it today. By the time they pay everything off, they owe 0. Okay, so 36 is our N. 0.83333333 is the IY. 15,422.4, hit the plus or minus button to make it negative is our present value, zero out the future value, and compute the payment. And that gives us $497.64. So that's our monthly payment. So $490, and we're a few cents off due to the rounding. So B is going to be our answer. The total interest paid, you could calculate by taking the $497.68, multiplying that by the 36 payments. That means they paid $17,916.48 for this vehicle. And then if you subtract out the $15,422.4 that they borrowed, that gives you this $2,494. But in this case, we knew the first answer. So, okay, then we have Marge and Tom bought a new car for $30,000. They put 25% down and will make monthly payments for 4 years. So find the amount of the monthly payment. So if we come back over here, clear this out. Our N is going to be the 4 years times 12. So there's 48 monthly payments. The IY is the same. It's the 10% divided by 12, which is the 0.833333, same as the last one. The amount that they borrow, so they bought the car for $30,000, they're putting 25% down, so you could subtract 25%, or you could multiply that by, you could multiply the 30,000 times 75%, but $22,500 is the amount that they're financing, so that becomes our present value. Again, it's a loan, so the future value is 0, and then we compute the payment. So 48 is the N, 0.833333 is the IY, 22,500, make that negative, is our present value, zero out the future value, and compute the payment. So that's $570.66 if I round it. Now, so then again, a few cents off, it's going to be A. Okay, then now we get into a mortgage. So they borrowed $106,000 at 10% for 30 years for a house. Find the monthly payment and then the total that they pay. So we'll come over here and clear this out. So again, we've got monthly payments. Whoops. So 12 times 30 years gives us 360 as our N. 10%, so it's the same rate again, divided by 12 gives us that 0.8333. They borrowed the $106,000, so that's our present value. The future value, it's a loan, it's a mortgage, so the future value is always 0. Compute our payment. Okay, so 360 is our N, the 0.833333 is the IY, 106,000, hit the plus or minus button to make it negative, push your PV button, zero out that FV, and then come back and compute the payment. So $930.22 or 23 cents is what I'm getting. So again, you can see the rounding though. And then the sum of the principals and interest, I'm going to take theirs. If you take their $930.78 or 68 cents and you multiply that by our N, our 360 payments, you get $335,044.80. So that's actually how much they'll end up paying for that house. Okay, then we have a movie star purchased a house for $779,537. He put 20% down, 9% for 4 years. So find the monthly payment and the total amount of the interest paid on the loan. So we come back over here, 4 years times our monthly payments gives us 48 as our N. 9%, now our rate's changing. Divide that by 12. And that gives us 0.75. The amount that they borrow is the $779,537. You can subtract 20%, and that gives you 623, 629, 60 as the amount that they borrow. Still a loan, so future value is always 0. And then we're going to compute the payment. So 48 is our N, 0.75 is our IY, 623, 629.6, hit the plus or minus button to make it negative, is our present value. No future value in a loan, clear that out, and then compute the payment. So we get $15,519.05. So then this one, again, it's like $3 difference, but it's going to be C. And then your interest paid, to calculate it as theirs, if we take that $15,522.14 and we multiply that by our 48 monthly payments, we're paying $745,062.72 for this house. If we subtract the 623, 629, 60, which is what we borrowed, this amount here, the difference is going to be the interest. So that's $121,433. Okay, then our last one. Whoops, I didn't mean to do that. Take that away. Oh, I maybe can't take it away. All right, let's go back. Let's create a new one. There we go. Sorry about that. Okay, so here we have Global Transport built a new building and amortized $6,200,000 for 20 years at 9%. So find our monthly payment. So our N is going to be our 20. Whoops. There we go. Okay, our N is going to be the 20 years times 12. So 240 is going to be our N. The 9% divided by 12 is that 0.75. That's our IY. The 6,200,000. Hit the plus or minus button to make that negative, is our present value. It's a loan, so we zero out that future value, and then now compute the payment. Okay, so 240 is our N, 0.75 is the IY, 6,200,000, hit the plus or minus button, is our present value, zero out the future value, and then come back and compute the payment, and we get 55,783. Now again, in this case, we gotta, it's because we're dealing with 6 million, the rounding error is a little bit higher, it's $17. But so then that is gonna be our answer. We're gonna miss the one because I left it blank, or it's telling me that, but that's fine, we're gonna go ahead and submit it. Okay. Oops. I must have skipped a couple. So this is the one that let me go back, or did I skip a couple? I think we did them all, but maybe I just didn't click the right buttons. So yeah, see, I think my cursor kept clicking D, and if I didn't correct it, it scored us wrong. So that should be everything though that you need to know. The other thing that's going to be on your test is the amortization function. So none of these in the review had it, but your take-home project does. And the amortization function is above the PV. So in your second menu button above the PV. So practice that.